Hello again, everyone. This is Mr. Smith, and this is 1.19 Graphing Quadratic Relations. This is actually the first time that you guys are going to see quadratic relations. So first things first, we have two different examples on the left with the red table of values. We have a linear relation that has y equals negative 3 over 2 x plus 5. If we reveal the y values here. So if you just calculate them out, you can use your calculator and you can solve them. And those are the values you should get. When you sub in negative 3 for x, you should get 9.5 for y. Negative 2 for x, you should get 8 for y. Negative 1 for x, 6.5 for y, and so on and so forth until you get to 3 for x and 0.5 for y. What's important to note in linear relations, as we've seen in the past, you guys would have seen this in grade 9, is the first difference is constant. So if we take a look at 9.5 to 8, we can see that the difference is 1.5. It's going down 1.5. And then 8 to 6.5 is down another 1.5, and then down 1.5 again, and so on and so forth, all the way through the y values. If I reveal the first difference, because we need a value over top of the 9.5, we can't actually find the very, very first difference, but from 9.5 to 8.5, it's down negative 1.5. So if I draw this here, we can see how this matches up. Usually it's drawn on a grid somewhat like this, and we have arrows pointing out what's going on. Similar idea in a quadratic relation, like we have over on the right with the blue table of values. We have y equals x squared minus 5. So if we sub in negative 3 for x, it'll be negative 3 squared, which is 9, minus 5. We should get 4 for the first y value. And then for negative 2, it's negative 2 squared. That's 4 minus 5. Should give us negative 1, and so on and so forth. And we just keep doing this until we fill out our first column here from negative 3 to positive 3 for the x values. What you'll notice here is the first difference from 4 to negative 1 is 5, because you go down 5 to get to negative 1. The first difference, again, for negative 1 to negative 4 is 3. The first difference between 4 and 5 is 1. And then we start seeing the first differences repeat, but in reverse. So once we go from negative 5 to 4, it's going to be positive 1. So it's going up 1. Negative 4 to negative 1 is going up 3. Negative 1 to positive 4 is going up 5. So if I reveal the first difference, we can see it now. And I'll just highlight this with my pen to show you how this is working. Whoa. There we go. Now, if you want to determine the second difference, this is where we do what we did to find the first difference, but instead of using y values, we're going to use the first difference values. So negative 5 to negative 3, it's going up 2. Negative 3 to positive 1, or negative 1 is going up 2. Negative 1 to positive 1 is going up 2. So our second differences are all going to be the same. Highlight this with our pen. My pen drew an extra line there. I'll try to erase it without causing any issues, but no promises. So now we can see very clearly how we get second differences. To graph this, I'm actually just going to use blue. I'm going to use blue for the quadratic relation. I'm going to plot the points, and then I'm going to reveal the graph afterwards, just because my hand isn't super steady on the tablet. If we're taking a look at negative 3 for the x value, positive 4, there's our point there. Then we have negative 2, negative 1. Negative 2, negative 1's right there. Negative 1, negative 4 is right here. And then 0, negative 5. Then our next point is 1, negative 4. 2, -1, then 3, +4. And that's how we would graph our quadratic relation. Now if I reveal this, we see pretty apparently that the dots were pretty much on point. The graph screenshot was a little bit off center, so I had to readjust for that. So there you go. That's how you draw a parabola. It's a bit of a curve instead of a line. So it's just a big curve, and it gets steeper as it goes further out. And it slowly flattens as it gets to the center of it before it turns around and starts steepening, going steep again. Another thing to note is it is symmetrical along the center of it. So in this case, it's just the y-intercept. That's where the center of this quadratic relation is. Linear relations. We have y equals mx plus b. The graph is a straight line. The first difference is the same. M is the slope. B is the y-intercept. So m and b are part of our equation up here. Y equals mx plus b. In a quadratic relation, the graph of a quadratic relation is actually called a parabola. You may have heard that. It's a curve, but it's named a parabola. The first difference is different. That means that it's not consistent like our linear relation. However, our second difference is the same. Some points to follow will be our step pattern. Step patterns will be multiples of 1, 3, 5, and 7, and so on and so forth. Notice that these are increasing by 2. It'll be multiples of these numbers, 1, 3, 5, 7. Sometimes denoted with a dash in between. I like to use commas because it's a sequence. The maximum and minimum point of a parabola is called the vertex. So in example 2, I want you to circle all quadratic relations. If I have a... And then you tell me which ones are quadratic relations. A big hint to that, it'll be x to the power of 2 will be the maximum power in the quadratic relation. Notice up here, the highest power is 2. So your answer should be A, C, not D because that's a power of 3. For B it won't work because we don't have a power of 2. E, we don't have a power of 2. This is actually a power of 1/2. We have a power of 3, so this is not one of them. F is not a quadratic relation. We don't have x to the power of 2 anywhere in G. And H. H is technically a quadratic relation. So now we're going to learn a little bit more about the step pattern. Points on the parabola follow a step pattern, which is the multiples of 1, 3, 5, 7. So we need to plot the points in a table and draw a smooth curve of best fit. Here we just plot our points. So now we're going to learn about the step pattern. Points of a parabola follow a step pattern of 1, 3, 5, 7, and so on and so forth. Here we're just going to plot the points and then draw a curve of best fit, and then I'm going to ask you if it's a parabola. So our first point is -3, -2. Next point is -2, 1. Then we have -1, 3, 0, 4, and vice versa on the other side. I'm just going to speed this up a little bit. There's our points plotted. If we were to check the step pattern, we can see that it goes over 1, down 1. That's good. That's our first step. Over 1, down 2. That doesn't follow our step pattern of 1, 3, 5, 7 already. So we go 1, then 2, and then 3. That's not a parabola. Therefore, it is not a parabola. It is not a parabola, and it does not follow the step pattern, which also means that the second difference isn't the same. The second difference is actually going to be different. Now we're going to talk about graphing using a step pattern. So first thing you do is you plot your vertex, which is your maximum or minimum value, and then you plot your points using the step pattern going up or down. Your step pattern will be 1, 3, 5, or some sort of multiple of that. So here it says use the step pattern to graph the following relations, and we have in red our vertex. So we're going to draw that in red. So in red we have 3, -4. Going to plot that first. Then we go over 1, up 1, because that's our first step in our step pattern, and it says we're opening up. And then over 1, up 3, because that's our second step, and then over 1, up 5. There's our point there. Same idea, the opposite direction. Over 1, up 1, over 1, up 3, over 1, up 5. And there's our parabola there. Next, I'm going to plot the points using blue. Now I have my blue marker. For the vertex, we have -4, 8. So -4, +8. And this time we're actually going to open down, and we have a bigger step pattern. It is still a proper step pattern because it follows a multiple of 1, 3, 5. The only difference is it's multiplied by 2. So we go over 1, down 2, because it's opening down. Over 1, down 2. Then over 1, down 6. Then over 1, down 10. Same idea, the opposite direction. Over 1, down 2. Over 1, down 6. Then over 1, down 10. So this one's going to be very, very steep and accelerate much quicker. And if you draw the line to fit it, obviously this shifted a little bit, but it's still pretty accurate and shows you a good depiction of our parabolas here. Finally, we have a word problem. Given the graph y equals -2 bracket x plus 2 end bracket new bracket x minus 10 end bracket, which represents the height of a garbanzo bean in feet after time x in s. Determine the initial height of the bean. So where does it start? Does it start at 80? Does it start at 0? Well, no, it doesn't start at 0 because we don't see anything down here. So what we actually see is right here, it starts at 40. So the initial height is 40 feet because our height's given in feet. When does the bean hit the ground? Well, if we follow the trajectory, we see that the height, we want to know when the height is 0. We can't go negative time, but we do have denoted by the x there, the time at 10 seconds. So it's 10 seconds until it hits the ground. What's the height after 7 seconds? So in order to do this, you're going to find where x is on our x-axis here. Trace it up to find our y value. So right here in the circle is our approximate height. I would say that's about halfway, so that would be about 53 feet. 54 feet is what the notes give us. So 54 feet would be appropriate, or 53. Because it is a graph, I would be a bit more forgiving. However, later on in the course, I do want you to use algebra to solve. So if I say use algebra, or solve it algebraically, then you actually have to sub in the 7 seconds into the formula that was given in the very first line up here. I put a box around it. But if you're just looking at a graph, it's okay to be within 1 or 2 units. Next, I ask you, when is the bean 70 feet high? Here we actually got to be a little careful. Because it is a parabola, there's actually going to be more than one time that this happens. So there's a time here and a time here. And then you trace it down to your x values, because that's going to give you your time in seconds. So the first time would be 3 seconds. Then the second time would be 5 seconds. The reason why we go here is because this is where 70 is on the y-axis. So I just traced 70 over here, circle, and then drew straight down, drew a circle, and then drew straight down, just to help me out. If you're doing this on paper, definitely use a ruler, and that should help you solve. With that said, that should be enough information for you guys to go on and do assignment 1.19. If you have questions, post them on Brightspace so that other students can see and answer them. Remember, you're supposed to at least post a question or answer a question at least once a week. You only have to do one or the other. If you want to do more, that would be great. It would help me out a lot. And make sure you upvote other answers that are right. And if you do something different, post that, because it's always neat to see how everyone solves things a little bit differently. Okay, you guys have a good day, and stay safe out there.